Typically, I do not do this section, so bear with me. I just want to introduce a little bit about EarthAtHome. The EarthAtHome project is sort of a one-stop shop, or the intention, sorry, I need to get rid of this window. The intention behind the EarthAtHome project is to be a one-stop shop for earth science, I guess, content and kind of materials for teachers and students. So I'm going to go through some of the features on EarthAtHome and occasionally pass it off to Don and Rob. And you can follow along if you want. You can explore while we're talking. But this is just kind of a quick tour through to give you an idea of what's available on the site. So the first thing I'm going to be talking about, and I'll put some links in the chat so you can follow along. So let's go to the home page first. So this is the EarthAtHome homepage, and link is in the chat if you need it. So the first thing I'm going to talk about is the Digital Encyclopedia of Earth Science. So just to go back to the home page, scroll down, or sorry, where are we? This top menu here, Digital Encyclopedia. So click on that, Digital Encyclopedia of Earth Science. So this has a number of different topics. Huh?
Do you want to screen share?
Oh, sorry. Yes, I do want to screen share. Thank you.
Sure.
Try this again. Let's see, which one do I want? This one. There we go. Now you can see it?
Yep.
Okay, great. Yeah, so I won't just be talking with you wondering what I'm looking at. So here's the homepage again. I put the link in the chat. So the Digital Encyclopedia of Earth Science is on this top menu bar, which has the major sections, including the regional guides, which we'll look at later, the Digital Encyclopedia, virtual science, and Don and Rob will be talking about some of that, and I think I will be as well. Additional resources, an about page, and of course, donate. So the first thing we're going to look at here is Digital Encyclopedia. And I've clicked on that, but here's the link as well in the chat. So scrolling down this page, this just covers some of the major topics in earth science. So earth system science, minerals, rocks, plate tectonics, and earth hazards. There's a section on geologic time and earth history, fossils, paleontology, and evolution. And we'll talk a little bit more about some of this later. But some of these links do take you to other PRI sites. So for instance, under fossils, paleontology, and evolution is the Digital Encyclopedia of Ancient Life, which is a bit separate from the EarthAtHome site, but is basically a digital textbook of paleontology. And then there's a whole section on climate change and energy, which has been put together by our climate team. So just to go back up and show an example of one of these pages, let's look at minerals. So everything starts with a header image, credits, a little thing that gives you an idea of when last updates were last done to the page. On the minerals page, there are PowerPoint files and image files that you can download for use in your classroom. These aren't available on every page that we have on EarthAtHome, but they are available on some pages. And then down here, there are contents, and the contents for the page have anchor links. So if you're looking for a specific topic that's in the contents, you can just skip down, for instance, mineral identification, and it'll zoom you down the page to the topic that you're interested in looking at. So here we have mineral IDs. Some of these are embedded videos. A lot of these models and videos for this particular page are taken from other Sketchfab and YouTube creators. So we do try to credit people who have created the other models or linked to the original models, so you can find those. So this just gives a lot of basic stuff about minerals, cleavage, hardness, all that stuff that you would typically teach in a minerals class. So I think that's sort of it for the general idea of what's on the Digital Encyclopedia. So the next section is virtual science, and Don is going to start that section. So I will stop sharing and hand it to him.
I'm muted. Whoops. I recognize that our participants are elementary folks, so I'll try and give attention to stuff that is more along those lines. And one piece of that I think cuts across the grade bands are the big ideas in earth science that we've laid out here, which is in the digital encyclopedia. So adapting to the audience, I will point you to that. And that just lays out what we think that if everybody understood just a few things about earth science, it should be these things. And you can understand them at a lot of different levels, starting at the elementary level and going up from there. So that's, I think, a relevant resource for you all. But not what's labeled on the agenda for me. So what's labeled on the agenda for me is talking about the VFE catalog and virtual fieldwork. So on the virtual fieldwork page, and let me put the link in the chat again. You can see our collection of virtual fieldwork experiences. But before we go there, let me say a little bit about the philosophy behind virtual fieldwork. It's generally not intended to replace getting outside with kids, but can do that in certain ways. One of the pieces of one key thought behind this is that we're trying to flip the problem on its head of having technology keep people inside of all ages, to using technology to document what's outside so you can share it with interested others. And therefore there's some info on how to make your own virtual fieldwork experiences, and some tools for doing that. And again, this can be done across the grade levels. But I will point out a couple of virtual fieldwork experiences, what we call VFEs for short, in the VFE catalog, which is this interactive map here. And we've got Michiganders and a Ontarian, is that right? So we don't have any VFEs in the database for that, but we do have them around the country. And when you click on any one of those, it'll open up a description in the sidebar with a picture at the top. That's Rob walking away there. And John is here. And a brief description and some links, a link or a couple of links for the resource. So you can click through, and this will give you an overview of sort of a user guide for the VFE. And you could click directly to the VFE from the catalog, or you can click to it from here in the user guide for it. And it's, let me actually flip back to the Google Doc. That'll just be quicker. At the heart of some of the VFEs is this graphic organizer, which again, I think, given that you're elementary folks, I think this cuts across the grade levels to some degree anyway. It might be a bit of a stretch for kindergarten, but for upper L, I think the big questions, the sort of guiding questions to structure the exploration, work across grade levels. So for many of the VFEs, the driving question is, why does this place look the way it does, where you swap in the name of the place you're looking at. And then there's a series of global questions in the middle. So how do you know what does it tell you about past environments and what does it imply about the future? And then there's some what we call arrow level questions that again can be addressed at multiple levels, starting in elementary school. So describe the shape of the land, what effects his water had on life in the landscape, and so forth. Then I think most of these questions anyway work for elementary students. And I think that's probably the 2 minutes that I'm allotted in for this piece in the agenda. And since John has joined us, I'm gonna stop sharing and have John introduce himself and hand it either to John or Liz for the next piece.
Hi, everybody. I'm John Hendricks. I'm at the meeting in Denver. So I'm going to hand this back over to Liz. I'm just participating today in case any questions come up.
Muted. Having a lot of technical issues today. So I guess the next section is the virtual collection. So let me get back onto the screen share. Okay. All right, so I am not on the right page, but we will quickly get there. So virtual collections is also under virtual science. Just click on virtual collections and I will also put the URL in the chat. So the virtual collections here encompass a number of different categories. We have rocks and fossils. So different types of rocks, igneous, sedimentary, and metamorphic. So just as an example of these, here's the virtual collection of igneous rocks. This probably maybe wouldn't be the most exciting thing in an elementary context, but it does give some examples of different types of rocks and what they look like, and they can be manipulated. But fossils maybe are a little bit more interesting. So let's look at some sort of fossil. Let's look at arthropods. So the fossil collections are done or sorted by major groups. So protists, animals, plants, and then I guess just other. So these are arthropods. These 3D models were made in-house by PRI. And so let's just go through the arthropods. Let's look at crustaceans. I don't even know what we have. Let's see. All right, so there are some different fossils and also some modern organisms mixed up in here. So let's just take a look at this crab. It's kind of cool. So on these 3D models, you can click and hold to rotate the model and look at it in 3 dimensions from every view. Some of these models do have labels put on them. And yeah, the recording will be shared on YouTube, so it can be watched later. And so these can be manipulated by the user just to look at different things. And these particular models don't happen to have labels on them, but some, like I said, some do. So basically the virtual collection is something you can explore if you don't have specimens in your classroom that you can look at just, you know, in a lab space or something. It's a place where you can send your students to look and see what these fossil specimens would look like. All of the virtual collection is available online for free. It's been put in the public domain for PRI, so you can use these models any way you want, including for 3D printing if you do want to make some physical specimens for your classroom. And so with that, I guess the next section I'm supposed to share here is additional resources. So I will go back up here. Let's see. I'm trying to remember where our additional resources were. I just had this. Let's go home. I'll just, apologies here. Oh, it's because I'm on the digital atlas. That's fine. All right, so back to the EarthAtHome homepage, additional resources is on the menu bar at the top. So you can either choose something in the drop-down menu or just go to the additional resources main page. So additional resources includes a number of different categories. One of these is the science road trip, which Don will talk about in a second and is probably of a lot of interest in the elementary school classroom. Also workshops, fossils of the United States, quick guide to earth science, frequently asked questions, and quick facts and other things that may be of interest, like geologic maps and topographic maps. So a few of these that I might want to highlight here: fossils of the United States is just a collection of fossils from different regions of the United States. These are all brought together into one page that you can explore. Right now we have a number of different regions, mostly in the Western United States and in the central part of the United States. We're working on the Midwest and the Northeast right now. And actually Midwest fossils are done. They're just not put on this page yet. So those are coming. How similar are fossils in the US to those in Canada? That might be a better question for John to answer.
Yeah, the answer is sometimes they're really similar and sometimes they're really different. It just sort of depends what age rocks are exposed in Canada that are sort of similar in age and an ancient environment to what you find in the United States. So in some cases, for example, there are Devonian aged fossils from around 380 million years ago or so in upstate New York that are really similar to those that can be found in Ontario. So it just really sort of depends, but yeah, there are some similarities.
Yeah, and Marion's in Toronto, so I think mostly pretty similar to Western and Central New York, and I mentioned that I vacation this summer on Manitoulin Island, which is really that's a continuation of the Niagara Escarpment. So the Niagara Escarpment runs the length of upstate New York, so the rock types here are going to be similar to there. And up around Sudbury, Sudbury has some very interesting and very different geology, but near Sudbury is very similar to the Adirondacks of New York State. So there's a lot of where there aren't fossils because that's metamorphic rock. But you'll see in some of the maps the sort of trend lines that continue, and you can picture them continuing into Canada, and at least near the borders, they're pretty. That continuation works pretty well.
Okay, so yeah, and we do have a collection of models of Devonian fossils from New York. So that may be of a special interest if you're in Eastern Canada as well.
Yeah.
All right, so fossils of the US, quick guides to earth science. These just explore various topics in earth science, like the geologic timescale, rocks, plate tectonics. So just gives an overview of everything. The frequently asked questions are really good for quick, concise answers to specific types of questions. So things like, what causes climate change? Why is carbon dioxide called the greenhouse gas? If you want something just very short, simple, and sweet, this is the place to look for it. And then, yeah, so other quick facts about the earth science of the United States and geologic maps. So I think really the kind of highlight of this page, if you're looking at a younger audience, is the EarthAtHome Science Road Trip. And Don's going to introduce that. So I will give him the floor.
Okay. And the Earth Science Road Trip, the link is here. And it's following Gilbert D. Snail around the country as he makes his way through the regions that are being developed in the regional guides. And you can read about him and you can follow him on social media to see where he is at a particular time. And you can see that we have trivia questions as he goes through the country, and you can check out those questions here for each state that he's getting to. And there are postcards from Gilbert. And he is working his way towards Michigan. He's not going to get to Toronto anytime soon, but who knows, maybe a future grant will cross the border for us. And I want to pause and say, we've got just 2 participants who are both elementary teachers. And if there's something in particular, if you've taken a glance at the resource and want to ask questions, we don't have to stick tightly to our agenda here when we've got just 2 people. And so, raise questions at any point. And I'm going to stop sharing and pass it back to Rob to say a word or two about, or pass it to Rob for the first time, I guess, to say a few words about the teacher-friendly guides when I didn't realize my video was not.
Okay. Hey, folks. So the first thing that I would like to do just very briefly is address that question about geology and fossils in Canada that we were just mentioning, and say a word about how you could figure that out. And so I'm going to share screen. John and Liz, correct me if I'm wrong, but I don't think we have a North American geologic map on EarthAtHome, at least not yet. But I don't know if you're familiar with the concept of a geologic map, but it is a map that shows the age of the rocks at the surface. It looks very complicated when you first look at it. And in fact, part of the goal of sites like EarthAtHome is to actually help make sense of this. It looks jumbled and almost random, but it really isn't. And
yeah, and Rob, I'll interrupt for just a second to say that our participants are from Toronto and Grand Valley State in Grand Rapids, Michigan. So they're both along the same line of rocks.
Right. Okay, thank you.
Yeah.
So, all right, so this is the bigger, this kind of shows you all of North America. And then I'm gonna click on, let's see, get to this, just to kind of zoom in a little bit, and you can see these purple and blue colors, and these all represent rocks that are around 300 to 500 million years old, something like that. And so you can see the rocks actually where we are located as an organization are here in this blue, called the Devonian period. It's a big part of Michigan. And then this light purple here is a slightly older period, and this darker purple is slightly older again, the Silurian and the Ordovician. And these also form part of the Ontario region and then up the East Coast. This area up here has rocks that are very ancient, billions of years old. They're among the oldest rocks exposed at the surface in the world. They're fascinating for that reason. And then in the western part of Canada, there are some rocks from when the dinosaurs lived, and a number of other periods. So Canada has a very rich geologic history. Michigan has a geologic history that is really in many ways quite similar to that of New York. So many of the fossils actually are not only similar, they may even be the same species from the same time intervals. So having said all of that, we, many years ago, we began creating a series of books called teacher-friendly guides to each region of the United States. We have not gotten to Canada, but the idea with each of these was to provide information that would make it easier for teachers to teach about their local and regional geology and fossils without having to have a deep background in the subject, or maybe if if you needed to remind yourself of the topic, maybe you moved to a new area, and so on and so forth. So they're basically intended to fill what we perceive to be a gap in the literature, where there's a lot of technical literature. There were some resources that were very specific to specific states or even smaller areas, and those, they're very useful. But of course, geology doesn't know anything about state boundaries, so the regions are bigger, and they're kind of bigger geologic areas, as Liz explained. So anyway, point is that we created a series of these books. Earth at Home is absorbing the content from these books and much more. There's much more to Earth at Home than just what is in these teacher-friendly guides. But anyway, this gives you some of the origin of some of the content that's being ported over, and also mentions that these do exist. Most of them are not very old. There is one for the Midwest US, for example, that has Michigan in it. And so it's also free. You can download the PDFs. We do sell printed copies, but that's just because it costs us something to make the printed copies. We also have one for climate change, and a couple on evolution. Those are also available in various, as PDFs, and eventually that content will probably make its way onto Earth at Home. And the thing about Earth at Home is that it is updating the content and adding lots of visuals and other kinds of things that are not available in the books themselves. So, but just so you know that those exist. And John, I will stop, or Liz, I will stop sharing and pass it back to you.
So I just quickly wanted to look a little bit at Earth at Home regional guides. Okay, and I will share my screen again. Why is this not sharing? Can you see the screen? It does not look like it's sharing. Here we go.
There we go. Now we got it.
There we go. So the regional guides are here under regional guides. Going to the main page, you can see that there is a map of the United States, and this map is color-coded and also labeled to show the physiographic regions. So the way this guide works is that the United States is broken up into, I think, 7 different regions. And then each of these regions is broken up into sub-regions based on the physiographic province. And in the chat, I put the link to the main Earth at Home page. So we scroll down, we can see the introductions to earth science topics, and then each region. So Southeast, South Central, Southwest, West, Hawaii are completed. The Northeastern United States is in progress, so is fossils of the United States. You may notice we're missing a key section since one of you is in Michigan, and that's the Midwest. The Midwest is also under construction. So I'm just going to look first at the West to kind of show you what's in each regional guide, and then I will show you some examples of pages. So here's the Western United States. In Earth at Home, the Western United States includes Washington, Oregon, Nevada, California, and Alaska. Scrolling down, we have the map and content. So some topics are covered at the full region scale. Geologic history, glaciers, climate, and earth hazards typically are. And then some are covered at the sub-region scale: rocks, fossils, topography, energy, and mineral resources. You may notice if you explore around the site, there's some variation in how things are treated. And some of this just has to do maybe with the amount of content or how the original books were written. So there is a little bit of variation in how things are separated. So in the West, we have a number of regions, including Basin and Range, which is Nevada and adjacent areas, Columbia Plateau, which is mainly Eastern Oregon and Washington, Rocky Mountain, which is really tiny, the Cascade Sierra Mountains, and then the Pacific border. And then Alaska is treated as its own thing, and it actually has its own separate pages for energy and climate because there are very specific topics related or specific information related to those things regarding Alaska, both because of its wealth of oil resources and also because of its high latitude position. It's affected differently by climate change, probably more severely than some other regions of the United States. Then at the bottom here, we have geologic and topographic maps for each state and earth science quick facts. And then finally a resources page. The resources page is basically citations and links to further resources that you can explore. Most of them are things that were not developed by PRI. And then of course at the bottom of the credits, which talks about the original teacher-friendly guide project and how we've revised it. So just to take a couple of pages here and look at them, we can look at fossils of the Columbia Plateau. So basically kind of the anatomy of this page, we start out with a cool image, the title, and this map shows the region that we're actually looking at, so the states and also the subparts of the state. The snapshot just tells you what the page is going to be covering. And John put in the chat, if you didn't see it, Northeast will be completed by June 2023 at the latest. So hopefully it'll be completed sooner than that too. Okay, so the snapshot, then we go to topics covered on this page. Again, these have anchor links, so if you want to skip ahead to a particular topic, you can. The credits, which again, just go through the teacher-friendly guide and how this was revised when the page was last updated, and then it talks a little blurb that talks about the header image for the page. So if you scroll down, these pages do vary a little bit depending on what the fossil content is for each region. So in this case, we're looking at Columbia Plateau. There's not necessarily a lot of Paleozoic or Mesozoic. A lot of the fossil record is in the Cenozoic, and it deals with John Day fossil beds, so Clarino Formation and younger John Day Formation and some of those. So this is a particularly terrestrial region. We try to make it visually interesting, and the content is presented maybe at a level that's more geared towards older kids, but it's something where you could probably take the pictures and information and make it more accessible to younger children as well. So this is basically a fossil page, and I wanted to mention, since our participants are from further east, that the Midwest fossil pages are done, but they are just hidden for the time being. So there is a central lowland of the Midwest right now, and I can put the link in there in the chat if you want to look at it. This one is the one that would cover Michigan. We don't yet have the regional map done for this section, but basically this largely focuses on the Paleozoic because those are the fossils available for that region. And we do, if I scroll down a bit, I think under the Devonian, have some Petoskey stone from Michigan. So these things are coming online. As John said in the chat, we're working on Northwest Central and Midwest, and these should be finished by about the end of the year, so December 2022 or January 2023. They are partially done, so some sections are available online now. And also the Northeast is under construction. Some sections of this were put up early as part of the EarthAtHome project, so there are some things available for the Northeast as well. Geologic history, glaciers, and a little bit for the Inland Basin region, which is one of the major regions in New York, and some specific things for the Finger Lakes. And also Northeastern Resources is available. So if you're interested in exploring more topics in Northeastern geology, some of which might also be relevant to adjacent parts of Canada, there's a whole list of resources here for different states and regions covering topics in geology. And then I think the other thing I was supposed to mention here was climate. So if we go back to the Western page and scroll up, climate is usually covered on the regional scale. So the layout of the page is the same with the snapshot at the top, the contents with anchor links, the credits, when was it last updated, the explanation of the header image. And then basically each of the climate pages on this website are kind of set up in the same format. So they go through present climate, past climate, and then predictions about future climate. So this just talks about basically temperature and precipitation in the western part of the US for present climate. Past climate is sort of a mix of, there we go. Past climate sort of a mix of geologic history of a region as well as what we know about its past climate based on the geologic evidence. And then future climate talks about the future, but it also talks about changes we're already seeing now due to changes in global temperature and climate. So in the case of the Western US, it talks about some of the recent heat waves, the drying up of water resources, and also things like snowpack and wildfire risk, which are really relevant to the West. And I should also mention that there is a Midwest climate page live. And I'm not working in the Northeast, I'm working on Northeast Energy. So eventually Northeast will be put up, but there is a Midwest climate page, and the total Midwest page will be put up when the whole package is complete. So that's regional guides to earth science. And I guess now we pass it off to explore and prepare to share. Don?
Sorry about that. Yes. For the next little bit, just poke around, and and it says the Western U.S., but really you can go anywhere and find something interesting about earth science of interest to you, and feel free to ask us any questions. And as I said at the outset, since there's only two of us, we might be less than 90 minutes, but poke around a little bit and come back with a question or a comment or a thing you found that you think is interesting. And it's 2:42 Eastern time, which is where most of us are. So why don't you just take 3 minutes and see if you can find a cool thing that strikes your fancy that you want to say a few words about. And I should put on music. Maybe I will. Okay. Did you find something fun to share with us? Or can you pretend?
I can say something.
Sure. Great.
Okay, so I'm from Michigan, of course, and I'm going to be teaching grades 3 through 6. That's my grade band. And I've taken a few like physical geography and geology classes, so like I'm really enjoying like the fossils pages and such.
Mhm.
And my parents were big rock hunters as I grew up. So like the Petoskey stones, I'm very excited about that in the fossil section. That was really neat. And I'm very excited for the Midwest part to come out in December or later. So
Great, great. Yeah, and I'll note too that I did my graduate work at Michigan State and was a Michigander for 7 years and taught at Kalamazoo College for a couple of years too. So I know the state. Marion, do you have a thought to share for us?
I'm having trouble with the internet.
Oh.
I'm up north, so I'm not in the city, so things aren't happening with any speed.
Okay. Well, that's too bad. Hopefully you've been able to see the things that are on the site. We are glad to stick around and have you explore and ask questions. It sounds like that's not really working for Marion at the moment. I think we can just take any more questions, and if there aren't any more with this group of two participants and 4 instructors, we might wrap a little early. Glad to stick around if folks want to see anything or ask anything or share any ideas for other things we might include in the resource or whatever.
I'm probably not going to be asking questions at this point.
Okay.
Because I can't get to the sites.
That's a good reason. It's a good reason.
And yeah, good to know that in some places it's challenging. It is a visually rich site, and that has as its downside that it's probably difficult to view in low bandwidth areas.
Yeah.
And it came up already, but emphasize that, I mean, 3 of us on this Zoom call are paleontologists, and I think we can all attest to the fact that the geology of Michigan and the Ontario area is really, really rich and actually kind of famous. We have New York is famous for some of the sedimentary rock that is in our area, and geologists and paleontologists actually come from other parts of the world to study the rocks in our area because they're thick sections that are very well preserved, very fossil rich, and so on. A extensive scientific literature that goes back well over 100 years. But the same is true of Ontario and Michigan, again, because they're not exactly part of the same geologic basin, but they're adjoining and have and share many of the same geological stories. So it is actually a very cool area. It may not seem like, oh, we don't have huge mountains here or something, but in fact, the story is quite rich. Often you have to look in creek beds and and that kind of thing, road cuts to see to find the rock record, but it's really quite good.
Any other thoughts or words of wisdom from anybody on the call? I think maybe we'll call it a wrap. A little bit early, but
Okay. Thank you for coming, folks.
Yes, thank you.
Thanks, everybody.
Yes, thanks, everybody.
Nice to meet you. Bye-bye.
Thank you, guys.